Hello, my dear colleagues from the Jubilar 10th Grid conference. I, I'm not sure for you, but I really didn't see me presenting in this virtual way. I really hoped to come to Novi Sad and to enjoy hospitality of our hosts and the hospitality of the city of Novi Sad, which with everything what it offers. Here I'm presenting the results of the research we made on the PCL zinc oxide coatings, and the title is the influence of the composition of the mentioned coatings on coated offset cardboard prints. My colleague and I used the summer ease with the COVID pandemic to conduct this research, and here you will see the results of it. So I tried to construct this presentation in 5 stages. First, I will try to mention what is the problem and why. Then afterwards, why we are conducting this research. In the third stage, we will talk about which materials were used, how we prepare the samples, and used methods. And then we come to the results of the research, and in the end we will draw some conclusions from it. At the beginning we talk about in general global printing market, which everybody thought that it will decrease, especially the conventional printing techniques and conventional printing products. Some of them really did decrease, and we cannot talk that the newspaper, magazines, commercial printing is in the same levels as it was 10 or 20 years ago, but in the same time packaging really increased highly, and that means when adding it that the printing market is increasing steadily for years, and the predictions are that it will continue to grow in years to come. As every aspect other in the industrial productions, we have to think green. That means that we are not allowed only to think about the primary purpose of some products in this kind of packaging material, so to protect the product inside and to improve the aesthetics and therefore marketing of the product itself. Then we have to think about environmental and its impact on the ecology. So where the problem lies, the improvement of packaging material for now is primarily done by adding some overprint varnishes, which then improve aesthetics or improve barrier properties or something similar. And a lot of them, which are today used, really don't do some improvement in the ecological part, so for composting or for recyclability. And therefore we were thinking about how to implement biodegradable materials, which will improve for sure composting of materials and could improve recyclability. So we thought about biopolymer, which can be used as a varnish base, in which we can add some particles which will then more improve more and more the behavior of these coatings when applied to the print. So this research was done to investigate for example, this nanocomposite, which is made from the PCL, which is biopolymer, and zinc oxide nanoparticles, which can improve when properly dispersed and applied on the print, improve the newly based material, some advantages like barrier properties or light fastness or whatever. In this first stage of the planned wider research, we just wanted to make investigation how this composite will, when applied, will improve or disable some properties of the print which are very important. For example, color reproduction, or water permeability or something similar. So for the conduction of this research, we chose two materials. One was uncoated offset paper. Both paper were in 300 grams per square meter, and coated paper was chosen by it. While its finish doesn't closes the surface so high, so these paper are more absorbative, and the coated paper which had gloss finish was the other one. The material, as said, we chose polycaprolactone, which is biopolymer and could be therefore biodegradable. We dissolved it in ethyl acetate, and afterwards we added some different mass concentrations of zinc oxide. The mass concentrations which were used in this research was 0.1, 0.5, and 1%. And the preparation of samples were in two stages. One was made in print house, which is PSO FOGRA certified, and the prepared sample were printed on the sheet fed printing press KBA Rapida 105. We're using quickset CMYK inks, and the printing was in compliance with ISO 12647-2 2013 ISO norm. That means that productions and some tone value increase and so on was highly determined, and it was under the strict boundaries. The solutions which we use as a overprint varnish were prepared by means of magnetic stirrer, where we put in the precise amount of the PCL and ethyl acetate, and then in airtight container was stirred for 120 minutes until the PCL was dissolved, and then it's prepared for dispersing the nanoparticles. The dispersing of nanoparticles was done prior to applying them on the print with an ultrasound disperser for 10 minutes. The coating of the prints were done by using the K202 control coater, using the standard coating bar number 3. That means that the wet coating thickness will be 24 micrometers, and the coating was done by applying always the same pressure and the same coating speed. The methods which were used for characterizations were determining of the CA-LAB color coordinates. We used TechCon SpectroDance. The specs for the measurements are provided in the paper, but we used the M1 filter and D50 light. And afterwards we calculated the color difference delta EAB and delta E2000. The idea behind the calculation of two equations were that delta EAB is used in the ISO norm, and we use it for calculating the color difference between the measurement on the sample and the given coordinates by the ISO norm, and delta E2000 is to evaluate the difference between the sample and the coated sample. Similar to that, we measured print gloss with Alcometer 407, and we calculated the difference delta G. We name it delta G by calculating difference between print before and after coating process. And in the end, we measured water vapor transfer rate by using the equation seen in the slide. We used the wet gravimetric cup method. And we come to the results part, and the results say, so here you can see on the left is delta E AB, on the right is delta E 2000. As said before, delta E AB is calculated between the measured sample and the predefined color coordinates given by the FOGRA PSO, and the delta E 2000 is calculated between color coordinates on the printed sample, which is not coated, and on the coated samples with different addition of the nano oxide, zinc nano oxide particles. We can see on the left that on uncoated paper, the differences on in comparison to the FOGRA PSO predefined values are lowered when the coating is applied uh, for the all inks except the magenta. And on the right side, we can see that the differences are highest on the black print, while on the others is lower than 1. On both sides, we cannot see really that the addition of zinc oxide is leading to some different color changes. On the coated papers, there is some different behavior. So on the right side, we can see that that the delta E 2000 values are even lower than on the uncoated paper, but we can see two trends. One is that the decreasing values of the color difference in black and the increasing values of color difference in magenta. And this increasing color difference in magenta, although it's really low, it's so for the highest is 1 at the 1% of zinc oxide. This is leading really to some acceptable changes in the variations in the predefined FOGRA PSO values, while we can see that magenta is on all samples really high, and in sample 0.5 and 1% of added zinc oxide nanoparticles is outside the defined standard. The print gloss, we can see that the changes on the uncoated paper on the left is almost none, and on the right we can see that adding zinc oxide is really increasing gloss. Water vapor transmission rate, we can see on both that coating improved barrier properties of the investigated papers. On the uncoated paper, where probably part of the coating is absorbed, the PCL is proving is giving very high result, while adding zinc oxide nanoparticles it's not improving, which is not the same on the coated paper, where we can see that the lowest water vapor transmission rate is achieved with the highest investigated zinc oxide concentration. To the conclusions, we can see that the only problem really was the coated paper, where magenta got outside the acceptable tolerance level with the 0.5 and 1% mass concentration. We saw that the gloss from the uncoated paper is not really changing, and while on the coated paper we increased gloss and permeability is increased, water vapor permeability is decreased when on coated paper with increasing zinc oxide nanoparticles. In general, we can use these proposed coatings, but we really have to see lower concentrations of the zinc oxide, or finding magenta, which will be lower at the beginning. We have to thank to our sponsors. The research is a part of the project, and with this, I will conclude. So if you need any additional information, please feel free to contact me. Thank you. Goodbye.